Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. In this video, we discuss the solutions of 4 problems from the section Permutations and Combinations. And this is the first video out of the first part of the 3 parts of the video devoted for permutations and combinations. Right. This question has appeared in the JEE Main exam held on 29 January 2025 in the morning shift. The given question is the number of 6-letter words with or without meaning that can be formed using the letters of the word maths, M-A-T-H-S, such that any letter that appears in the word must appear at least twice is. I will read the problem once again. The number of 6-letter words with or without meaning that can be formed using the letters of the word M-A-T-H-S such that any letter that appears in the word must appear at least twice. Right. Let's now discuss the solution of the problem in detail. We are given the word maths, and this word maths has 5 distinct letters. They are M, A, T, H, S. What is our task? Our task is to form 6-letter words where any letter that is used must appear at least twice. This condition at least twice has come because we are only having 5 distinct letters. If you use any one of the letters in the 6-letter word, then that must appear at least twice. The valid permutations of 6 into letter counts where each count is greater than or equal to 2. So you have to divide 6 into the sum of the positive integers where every letter count must be greater than or equal to 2. Every letter must appear at least twice, that is the one. You have to divide 6 in such a manner where you have to divide 6 into letters counts, where each count is greater than or equal to 2. They are 6. 6 means one letter repeated 6 times. 3 plus 3, that means 2 letters. Each letter is repeated 3 times. 2, 4. 2 plus 2 plus 2. I will explain that. Case 1. Choose one letter from M-A-T-H-S and use it 6 times. That is for 6. Right. So the number of ways of choosing one letter from 5 letters is 5C1, 5 ways. And the number of distinct arrangements, these are the arrangements, that is arrangements of 6 identical letters is 1. Only one way you can do that. By product rule of counting, the total number of 6-letter words is 5 into 1, that is 5. Let's go for case 2. Choose 3 letters and each letter appears 2 times, thereby X, Y, Z. X is repeated 2 times, Y is repeated 2 times, Z is repeated 2 times. Right? So now the number of ways to choose 3 letters out of 5 letters is 5C3, that is 5C2 is 5 into 4 by 2, that is 10. The number of distinct, now for each selection, for each such a selection of choosing 3 letters, the number of ways to arrange the letters will be 6 letters, 6 factorial by, and 3 letters, each is occurring 2 times. Therefore, 2 factorial into 2 factorial and 2 factorial, that is 720 by 8, that is 90. By product rule of counting, the total number of 6-letter words will be 10 multiplied by 90, that is equal to 900. Right. So that's the one, and so far we have counted 2 cases. In the first case we got 5, the second case 900, 5 plus 900. Go to the case 2. Case 2 is 2 plus 4. That is, choose 2 letters, one appears 2 times and the other appears 4 times. Right. So, in these 2 subcases will arise. So, X, Y, and X is appearing 2 times, Y is appearing 4 times. Right. So, number of ways to choose 2 letters from 5 letters is 5C2 is 10. And for each such a selection, the number of ways to arrange the letters is 6 letters, in which 2 of them are alike, that is X, and 4 of them are alike, that they are Y, that is 6 factorial by 2 factorial, 4 factorial, that is 720 by 2 into 24, that is 15. 15 into 10, 150. Therefore, by the product rule of counting, the total number of 6-letter words will be 10 into 15, 150. There is the other case, the subcase B, wherein X appears 4 times, Y appears 2 times. So, X appears 4 times, Y appears 2 times. So, counting like this, similarly, the total number of 6-letter words will be 10 into 15. This will be same and this will be same. So, 10 into 15, that is 150. Right. So, case 3 has 2 subcases. In each, we got 150, 150. Case 4, choose 2 letters, each appears 3 times. So, 2 letters, X appears 3 times, Y appears 3 times. Then, number of ways to choose 2 letters from 5 is 5C2 is 10. And for each selection, the number of ways to arrange the letters will be 6 factorial by X 3 times, Y 3 times, 3 factorial and 3 factorial. So, when you simplify, you will get 20. So, the total number of 6-letter words in this case is 10 into 20, that is 200. So, now the grand total we will have. Now, thus total number of 6-letter words will be 5 plus 900 from the last slide. And in this slide, we got 2 into 150 plus 200. Add all of them, you will get 1405. That's the answer. So, the answer to this question is 1405. Certainly an interesting question. Right. We move to the next question. This is the question that appeared in the JEE Main exam held on 28th January 2025 in the second shift. The given problem is the number of natural numbers between 212 and 999 such that the sum of their digits is 15 is. So you have to choose those natural numbers between 212 and 999. When added, their digits must come 15. Right. Let's now discuss the solution of the problem in detail. Let x, y, z be the three-digit number. Between 212 and 999, the sum of the digits x plus y plus z must be 15. Agreed. Can x be 1? No, it can't be. If x is 1, it will be a number 100 and something. But 100 and something is less than 212. That's not a candidate for us. Therefore, x will not start with 1. Right. So, x starts from 2, let us say 2. Then, y plus z must be 13. So, that x plus y plus z is 15. Now, y plus z is equal to 15. How do you select y and z? When y, suppose you say y is 0. You can't have 0 plus z is 13 and z is 13. It's not. Y, z are digits 0, 1, 2, 3, 9. So, therefore, it starts from 4. Even if suppose it starts from 3, let us say. Then 3 plus z is 10. Then z will be 10. 10 is not a digit. 10 is a number. So, now y comma z will be 4 comma 9, yes, 13, 5 comma 8, 13, 6 comma 7, 13, 7 comma 6, 13, 8, 5, 9, 4. That means what is the three-digit number? 249. 249 when you add 2 plus 4 plus 9 is 15. 258. 2 plus 5 plus 8 is 15. So like that. So how many possible numbers are there? 6. 1, 2, 3, 4, 5, 6. Now let us take x is equal to 3. Then y plus z will be 12. Then y comma z will start from 3 comma 9, 4 comma 8, etc. up to 9 comma 3. How many these? These are 7 in number. So x is equal to 4. Y plus z is 11. Then y comma z will be 2 comma 9, 3 comma 8, etc. 9 comma 2. The number of numbers is 8. X is equal to 5. Then y plus z will be 10. So that the sum is 15. Y plus z is 10. Then y comma z will be 1 comma 9, 2 comma 8, etc. 9 comma 1. They are 9 in number. 4. X is equal to 6. Y plus z is equal to 9. So y comma z will be 0 comma 9, 1 comma 8, etc. 8 comma 1, 9 comma 0. They are 10 in number. You can count. Now x is equal to 7. Y plus z is equal to 8. Y comma z will be 0 comma 8, 1 comma 7, etc. 7 comma 1 comma 8 comma 0. They are 9 in number. X is equal to 8. Y plus z is equal to 7. Y comma z will be 0 comma 7, 1 comma 6, etc. 6 comma 1, 7 comma 0. They are 8 in number. When x is equal to 9, y plus z is equal to 6, then the number is 7. So we can't take x is equal to 10. So that's all. So the required number of natural numbers will be, that means those natural numbers between 212 and 999 such that the sum of their digits is 15 is, add all of them. 6 plus 7 plus 8 plus 9 plus 10 plus 9 plus 8 plus 7. That is 64. So the answer to this question is 64. So that is the detailed discussion of the solution of this problem. We move to the next question. This question has appeared in the JEE Main exam held on 24 January 2025 in the second shift. The given question is, the number of functions f from the set consisting of 1, 2, 3 up to 100 to the set consisting of two elements 0, 1 that assign 1 to exactly one of the positive integers less than or equal to 98. That means from 1 to 98, f will send exactly one letter to 1 and the remaining to 0. And what happens to 9900? That will be mapped to 0, 1. Right? So now, solution. Let x be any element of 1, 2, 98. Right. Now, let fx, f suffix x means it's a function, depends on x, is a mapping from 1, 2, 98 to the set consisting 0, 1 be a map defined by fx of t is equal to 1 when t is equal to x, is equal to 0 otherwise. That means when t belongs to 1, 2, etc. 98 minus the singleton x. So that means it is sending. This is a function which assigns 1 to exactly one positive integer less than or equal to 98. Yes, this is doing. But what happens to the remaining? That is the question. So now that means for each x belongs to the set consisting of 1 to 98, we have a function fx which maps x to 1 and the rest to 0. For each x, we associate a function. So how many functions? So therefore, how many functions will be there? Such functions will be there. The number of functions that map exactly one of the elements of 1 to 98 to 1 and the rest to 0 will be 98 because we have 98 choices for x. Now the question is, what happens to the remaining 9900? 9900 will go to 0, 1 because no condition is there on it. Therefore, the number of functions mapping the set consisting of 99, 100 to the set consisting of 0, 1 is 2 square because the number of functions will be the domain has 2 elements and the range has 2 elements. So it is 2 power 2 to this to the power of this 2 square. But now club these two things. That is the function. Let f be the function from 1 to 100 mapping to 0 to 1 be a map defined by f of t will be fxt if t belongs to 1 to up to 98. F of t will be 0 or 1 if t belongs to 99 to 100. This will be the required functions. How many functions will be there? Such functions. So the required number of functions is given by 98 multiplied by 2 square by product rule of counting, and that is equal to 392. That is the required answer. Right. That is the detailed solution for this. It is a very simple and straightforward question. Right. We move to the next question. This question has appeared in the JEE Main exam held on 24th January 2025 in the morning shift. The number of 3-digit numbers that are divisible by 2 and 3 but not divisible by 4 and 9 is. It is a very simple question. Let's now discuss the solution of the problem in detail. The 3-digit numbers are 100, 101, 102, etc., 998 and 999. Therefore, how many number of 3-digit numbers are 999 minus the 2-digit number of 2-digit numbers, that is 99. That is 900. Now, how many of them are divisible by 2 and 3? And the GCD of 2 and 3 is 6. So it amounts to say how many of them are divisible by 6. So the number of 3-digit numbers divisible by 2 and 3, that is by 6, because the GCD of 2 and 3 is 1, is given by the greatest integer function bracket 900 by 6. It's not needed here, the bracket. Why? Because you are getting exactly 150. Right, is equal to 150. Anyway, in a general setup, this is the 150. Now, how many of them are not divisible by 4 and 9? So let us first of all say how many of them are divisible by 4 and 9. 4 and 9, the GCD is 1. Therefore, the number of 3-digit numbers divisible by 4 and 6, 4 and 9. This is not 6. 4 and 9, 4 and 9, it's not 6, 9, by 36, that is by 36. Why? 4 comma 9 is 1, that is the GCD. Therefore, the number will be the greatest integer function, bracket 900 by 36. Here also it is exactly divisible by that. So, it is 25. So, therefore, the number of 3-digit numbers that are divisible by 2 and 3, that is divisible by 6, but not divisible by 4 and 9 is 150 minus 25. Not divisible, but not divisible. That is 150 minus 25, that is 125. So, that's your discussion of those problems that have come in the examination. Right. I am sure that you understood the solutions of these problems. I thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am sure that we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.